Okay, so we're on method number 2, Desmos graphing, and this is gonna be page 11 of your notebook. Again, when we're done, just fold it in half, cut glue, be smart, be creative, be great. Okay. So we have the problem here where we're going to figure out the Center for Disease Control and Prevention. They have guidelines for the target heart rate and beats per minute when an adult that an adult should try to achieve during moderate intense physical work activity. Have any of y'all ever been on a treadmill and you saw the little BP monitor thing that says it asks you your age and it tells you need to try to get into this heart rate or stay here to maximize your calorie burn and physical fitness and all that good stuff? This is what this chart is basically telling you, right? So we have our age, and it says your age in years, 20, 30, 40, 50, 60, 70, and it has your target heart rate, okay? Do you see a pattern already here? What do you notice?
As the age goes up, the beats per minute go down.
Exactly. As you get older, they're saying, okay, your heart rate, it's all right to work a little less hard, right? As you get up there, okay? So when we look at this, our age is our independent variable, correct? It's a thing that's happening that's going to control the next thing, right? And so therefore our heart rate is going to be our dependent variable, our Y. All right. So we're going to go through the steps to do Desmos. The steps to getting the scatter plot in Desmos goes as follows. First, you're going to go to desmos.com/calculator. Make sure you spell calculator right because the page won't work. You're going to click on the large plus sign at the top left. Then we're going to click on table and we're going to input our information. If you need an extra column, you can always type Y2, but for this data set, we only have one Y, right? And then you're going to type in your table values and we're going to adjust the screen to see all of our points. All right. After that, then we're going to follow the steps to find our regression model. And yes, literally you're typing what is highlighted. We're going to type the Y1 squiggle line, what is what is it thing called? I don't know. I can't think of it. I always forget. And I feel so bad for calling it a squiggle line. Don't come for me. Okay. Y1 squiggle line MX1 plus B. And you type it exactly like that. And then we'll have everything we need. Are we ready? Okay, I do not know where I put my chart at, so someone's gonna have to read the numbers to me. I'm gonna add my table, and I start at 20, right? Yes, 20, 30, 40, 50, 60, 70. And what is the BPM for a 20-year-old? 150 for a 30-year-old? I just told you I don't have a paper.
Oh.
A 30-year-old.
133.
Okay, 40-year-old. 50. 60. and 70-year-old. Okay. All right. All of my information has been put in. That's what my table looks like. Anyone had issues getting to the table or inputting into the table? Yes.
How do I get to the table?
You press the plus sign at the top left. What? On the left or the right? You went to the right. Ah. The other right. Okay. Now, once we have that in there, do we see our points? Oh no, we don't see our points. Something's not right. No, it means that we need to adjust our window, okay? Adjusting our window, notice how I pulled it just to be in quadrant 1. Why am I only in quadrant 1? They're positive, right? I only in quadrant 1. However, are my Y values and my X value large enough to accommodate my table? The answer is no. So we're going to click on the little tool button here. And we're going to adjust the max and min values of our X and Y value. Does that make sense? So I'm going to click here. Now, what would be a good max for me to have for my X value? 70 or higher, right? I'm gonna go with 80, so I can be a little off, a little extra. And I'm gonna count by 10 because I don't want a whole bunch of lines. On my y, what would be a good max value for my y?
177.
177? Is that what we said? Yeah, it works. And now, do I see my points?
Yes.
I do. I adjusted my windows in order to see my scatter plot. Okay, that's where that using math common sense and just general common sense comes into play. They're like, oh, it didn't work. I don't see anything. No, 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 no. We gotta do a little extra, okay? All right, what type of relation do we have here? What type of scatter plot do you see? It's a negative linear, right? So we know that we have a negative linear relationship here. So we're going to find that negative linear equation, all right? So to find the equation, we're going to go to our Y2, I mean our text box 2, and we're going to type in our algorithm for Desmos to follow. Y1 swiggle mx1 plus b. Okay, and does it find it for me? Yeah. Perfect. So from here, I can write my equation. So I'm going to write my equation in text box 3. We have y equals negative, and we're going to round to the nearest thousands for this one. 842 thousandths x plus 162 and 95 thousandths. Oh, well, it should be 3 because that 8 rounds the 2 up to a 3. Just a little. All right, so I'm going to pause here, check, come around, make sure we're all okay at this. Yes. All right, so you see these numbers right here? This R is called your correlation coefficient, okay? What your correlation coefficient is telling you is how close to being a linear function it is, okay? The closer it is to -1 or to +1 is how close to accurate it is to being a linear function. If you look right here, you see that we didn't go through all of our points, right? Because we didn't go through all of the points, notice that our correlation coefficient isn't -1, right? If we went through all of the points, then it would be a -1. But we went through 98% or close to our points. Okay, that's called your what again?
Our correlation coefficient is how many points we actually have.
You know, your correlation coefficient is this R value right here.
Yeah.
And it's the accuracy of your linear relation. Okay, so we knew it was a negative linear, but is it perfectly negative linear with these points? No, it's not perfectly, but it's pretty darn close with being at -0.98. Okay, and it's negative because it is going down. And if it was positive, then we want to be close to +1. Okay. All right. So the remaining part of the notes, you should be able to use what we have to answer. When you're looking for a value on a graph, so let's just say I want to know if I am 35, what should be my BPM, right? When you're in Desmos, you just hover, like you'll click and hover across the graph to find the value that you're looking for. So if I'm looking for 35, I'm going to hover. I'm almost there, somewhere in that weird spot. Oh. Not there. Oh, so 35. At my age, if I want to have a good workout, I need to maintain a BPM of 132.5 knots. Okay. Your other option is type it in. If I have an equation and I know my X, what do? I plug it in. So I would type in -0.843 times 35 plus 162.095. And what does it tell me? 132, okay? So you're gonna do, we did A, you're gonna do B, C, and D at your table. And that is the rest of today. So you're doing, we already did this part together. Now you're doing B, C, and D at your table. And I will be here to help and assist. Okay, again, really quick, why is correlation coefficient important? Anyone?
Wait, what'd you say?
Why is the correlation coefficient important again?
Because they have less to be a linear function.
How close it is to being a perfect linear, right? So we're looking at between -1 and 1, right? -1 means I'm a perfect negative linear. Whereas +1 means I am a perfect positive linear model. Does that make sense? Was our model perfect? No, but pretty darn close. Okay. All right. Great day, finish. And that is it for this section.